All right, this video is to help you complete the October 26th distributive property and like terms assignment given by Ms. Traub. This is exactly how it's going to be looking in Power School. Okay, so if you have a 0 for this right now, then watch this video, complete the problems, and get it turned in. So to solve these problems, we are going to need to distribute and combine like terms, and then solve. Okay, so we have a lot of steps on some of these problems. So in number 1, I see that there are parentheses. Anytime I see parentheses in an equation, I'm going to need to distribute. Okay, and think parentheses first, just like you did for order of operations. So the number that is directly on the outside of the parentheses is the number you are distributing. And this plus sign goes with the 2. So we are going to distribute a positive 2. Now, we're not going to do anything with this 3x. So I'm going to go ahead and write it down, 3x. And again, I'm going to distribute this positive 2. So I'm going to do positive 2 times 3x and positive 2 times, think of that as being a negative 7. So 2 times 3x is 6x, positive 6x. Again, positive 2 times positive 3x is positive 6x. Now we're doing positive 2 times negative 7. Positive times a negative is a negative. 2 times 7 is 14. Remember, you do get to use a calculator if you need it. So if you needed help with 2 times negative 7, use that calculator. Whoops, I guess I need to turn mine on in order for it to work, right? 2 times negative 7. All right, there is that negative 14 equals 4. All right, step 1, done, distributive property. Step 2, do you notice how there's a lot of stuff going on over here? Okay, usually we just have like 2 things. We only have one plus or minus sign. But on this one, we have 3 terms. So now we want to combine like terms. Like terms have exactly the same variable, and if the variable has exponents, then the exponents are the same. So this has an x, this has an x, neither x has an exponent. Technically, the exponent is a 1, but we don't show that. Okay, so we can combine 3x and 6x. 3 plus 6, 9x, minus 14 equals 4. Now it's solving a 2-step equation like you've practiced. To get rid of minus 14, we're going to add 14 to both sides of the equation. Bring down your 9x. 4 plus 14 is 18. Last step, get rid of multiplying by 9 by dividing by 9. And 9's cancel out. 18 divided by 9 is 2. So there is our solution. Now, Ms. Traub, in order to get credit, Ms. Traub wants to see your work. So please make sure that you write the work. Even if you need to pause the video, if I'm going too fast or you get distracted, pause the video and write out the work. Now, if you want to start trying some of these on your own, you could always pause the video, try it, and then watch the video. Or maybe you only need certain problems, so then you can fast forward the video. Do whatever you need to do. Okay, this video is here to help you in however you need it. So number 2 is very similar to number 1 in that I have parentheses. So parentheses first, I need to distribute first. It's a little bit more challenging than problem number 1 because I'm going to be distributing a negative 5. So that minus sign in front of the 5 is super important. That minus sign looks like a negative sign because it is, okay? Minus and negative mean the same thing. Now this 10x, I'm not going to do anything with my 10x yet. So I'm just going to bring it down. And again, I'm going to distribute my negative 5 times 2x and my negative 5 times 4. So negative 5 times a negative 2x. Now, I can't put an x in my calculator, okay? But I can do negative 5 times negative 2. And this is how you would do that. Negative 5 times negative 2. You can see my screen here, -5 times -2. It's a positive 10. Two negatives make a positive. So a positive, you need that positive sign, 10x. Remember that x was there? All right, next we're going to do -5 times +4. -5 times +4. -5 times 4 is a -20. Equals -60. Okay, next, let's combine like terms. So we have two terms that have an x, a 10x, and a 10x. 10 plus 10 is 20x minus 20 equals -60. Now, two-step equation to solve. We want to get rid of -20, so I'm going to add 20. 20s are gone. 20x equals -60 plus 20. Use that calculator. -60 plus 20 is a -40. And now your last step is to get rid of multiplying by 20. So you're going to divide by 20. Now, I already have in my calculator, I still have that -40. I didn't clear the calculator, and that's going to save me some time. I'm going to leave that -40, and I'm going to do divided by 20. So again, divided by 20. And I get -5. I'm sorry, -2. All right, number 3. I see I have the distributive property right out front that makes it a little bit easier. I am distributing a negative again, so let's be very careful. -6 times x and -6 times -7. Now, if you just have a variable and you do not see any number in front of the variable, there actually is an imaginary 1 right there. This is a 1x. So when we do -6 times 1, it's just -6. So -6 times x is just -6x. And then we have -6 times -7. Let's use our calculator for that. -6 times -7. I highly recommend putting these in the calculator yourself, not just waiting for me to do it. You need to practice how to use these calculators correctly for these negative numbers. So -6 times -7 is a positive 42. Positive sign, 42. And then the rest of the equation, -8 equals 22, we just bring straight down. Next step, combine like terms. So in the last two equations, we've been able to combine terms that both have an x. But if you notice, these two numbers do not have an x. Now, I want to be very clear that when you're combining like terms, you can only combine things on the left side of the equal sign with things on the left, and things on the right-hand side of the equal sign with things on the right. You can see there's nothing over there with the 22, okay? But we can't combine this 22 with anything else. So I'm going to combine this and this, a 42 and a -8. Now, we already have 42 in the calculator. -8 is 34. So -6x, positive 34, it equals 22. Next step, get rid of this plus 34 by subtracting 34. -6x equals 22 minus 34. 22 minus 34 is -12. And your last step, get rid of multiplying by -6 by dividing by -6. X equals, now I need to do -12 divided by -6. I already have a -12 in my calculator, so leave it and then hit divided by -6. So we had -12 divided by -6 is +2. Number 4. All right. Super challenging thing about number 4 and number 5, by the way, is that your variable is on the right-hand side of your equation. I highly recommend doing what I'm getting ready to show you. I would take everything that you have over here on the right-hand side of your equal sign, and I would move it to the left-hand side, okay? And then I would put equals and take this 148 and move it to the right, right? So we're just rewriting this. Make sure that whatever it says is exactly what you write down. Do not change the order of anything over here. So we have 8, negative 5x, minus 7, plus 4. So again, I wrote it exactly like it's written. Then I'm going to put my equal sign, 148. Now this problem looks similar to the problems that we have been solving. Most people prefer to have the variable over here on the left-hand side. You can solve it the way it's written originally, okay? There's nothing wrong with solving it that way. It's just more challenging, okay? That's why I'm giving you the advice of rewriting it. Now we're ready to distribute. We're distributing the 8. 8 times negative 5x, 8 times negative 7. 8 times negative 5x, 8 times negative 5. 8 times negative 5. Negative 40. So negative 40x, 8 times negative 7. 8 times negative 7 is negative 56. I didn't do anything with plus 4, anything with the equals 148. Now time to combine like terms. Over here, we have 3 terms. We only have 1 term with a variable, so we're going to combine these 2 terms, okay? Negative 56 and a positive 4, just negative 56 plus 4. You can use your calculator for that. Notice I already have negative 56 in there, so I can just hit plus 4. And I get negative 52. So we have negative 40x, a negative 52 equals 148. Now to get rid of this negative 52 or minus 52 by adding 52. Bring down your negative 40x equals 148 plus 52 is 200. Last step, get rid of multiplying by negative 40 by dividing by negative 40. We get x equals 200 divided by negative 40. 200 divided by negative 40. And I end up with negative 5. Make sure you're boxing in your solutions, please. Okay. All right, we have one more equation to solve in this section, and it's number 5. Let me fix my camera a little bit here. There we go. So in number 5, very similar to number 4, we want to rewrite number 5. Take everything that's over here on the right-hand side of the equal sign and move it to the left. Just be careful that you leave it exactly like it's written. 2 parentheses, negative 6x plus 7 parentheses plus 7x equal sign 29. All right, next, we're going to distribute this 2. It's on the outside of the parentheses. Distribute 2 times negative 6x, 2 times positive 7. 2 times negative 6x would be negative 12x. 2 times 7 would be a positive 14. Bring everything else down. Next step, combine like terms. You have 3 terms over here, so we need to combine something before we start doing inverse operations. This term has an x, this term has an x. So we can combine these two terms because they are like terms. We're going to combine the numbers out in front of the x. Those are called coefficients. Negative 12 and 7 are coefficients. Negative 12 plus 7 is what I want to do. Negative 12 plus 7 is a negative 5. X. Bring down your plus 14. Bring down your equal sign. 29. Now let's do our inverse operations. The inverse of adding 14 is subtracting 14. 14s are gone. Negative 5x equals 29 minus 14 is 15. And your last step, get rid of multiplying by negative 5 by dividing by negative 5. Negative 5s are gone. X equals 15 divided by negative 5. 15 divided by negative 5 equals negative 3. Box in your solution. All right, number 6. Number 6 looks really similar to that, the bonus problem that was on your equations test. So if you didn't do that bonus problem, maybe this will help you, okay? It says the perimeter of the following rectangle is 24 units. If the width is 3, what is the length of the rectangle? So let's write down what it's telling us. It says the perimeter, capital P, is 24. The width, lowercase w, is 3. What is the length? I use always a cursive L for that. I'm going to put a question mark. Okay. Now, before we figure out what is the length, which is this right here, okay, we need to solve for x. I can't figure out this unless I know what x is. How do you find perimeter? What is perimeter? Perimeter is the distance around a shape. And we find the perimeter by adding up all of the sides. Now, I know that they only have 2 of the sides labeled, but we are adding up all 4 sides. So that means this 3, there's a 3 over here. And this x plus 4, there's a x plus 4 up here as well. When we add up these 4 sides, that's the perimeter, and they're saying that the perimeter is 24. So you can really write this equation a lot of different ways. Most people just kind of like to start at one spot and work their way around if they were really going to add. So if they said 3 plus x plus 4 plus 3 plus x plus 4. Kind of looks like a mess, doesn't it? So again, we had 3, x plus 4, 3, x plus 4. Now, you could write this in a lot of different ways. You could say, well, what if I just did 3 plus x plus 4 and multiply the whole thing by 2? Because there's 2 3s and 2 x plus 4s. Or what if I grouped my 3s together and then grouped my x plus 4s together? Some people like that method as well. So you still have those 4 sides, okay? And this would mean the same thing because you are distributing 2 3s and 2 x plus 4s. Okay. I'm just going to leave it like this because I know from teaching it in the past, that's how a lot of people just like to write it. So then it equals the perimeter, which they told us is 24. Now we're going to need to combine like terms. We have a lot of terms over here. So let's first combine our terms that have a variable. So we have this x, that the sign in front of the number goes with it. The sign in front of a number goes with it. That plus sign goes with the x. That plus sign goes with the x. So remember we talked about that if you only have a variable and you don't see a number out in front, it really is a 1. So 1 plus 1, that means 2x. Now let's combine our other numbers. Those other numbers that don't have variables are called constants. 3 plus 4 plus 3 plus 4. 3 plus 4 is 7, plus 3 is 10, plus 4 is 14. So plus 14 equals 24. Now, that looks like a more reasonable equation, right? Minus 14. 2x equals 10. Divide by 2. X equals 10 divided by 2 is 5. Now, if I were to box this in, would I be answering the question? Remember, the question is, what is the length of the rectangle? The length of the rectangle. They're not asking me what is x. What is the length of the rectangle? The length of the rectangle is x plus 4. So I need to take this x and add 4 to it. This is my answer, 9. So you have to read very carefully. Make sure you're always answering what the question is asking. It's possible that it could have asked, what is x? But it didn't. It asked, what is the length? Okay, so you had to substitute x into this expression right here in order to be able to find the length. Okay, we have the back side of this paper as well. For number 7, 95 people went to a convention in San Francisco. They took 3 large vans and 50 people traveled by car. How many people fit in each large van? Write an equation first and then solve. So I'll be honest, a lot of people have trouble with these problems. Writing equations is challenging for most people. So don't feel like you're just dumb or whatever you want to call yourself because you have trouble writing equations. Everyone has trouble writing equations. So what I recommend, besides reading the problem first, is kind of putting yourself in that problem. Pretend like you were one of these people going to the convention in San Francisco, okay? 95 people went to the convention. That's how many total people went. They took 3 large vans, okay? And whenever you see and, that usually means adding 50 people traveled by car. So again, the way that they got to this convention, think about it. Your 2 options of getting to this convention would be taking the van or taking a car. So you can take the people that are taking the vans, people that are taking the car. This would be the total people. Now, this is not the equation that Ms. Traub was looking for. Okay, this is just our starting point. So now let's think about how to replace these words with numbers or symbols. Okay, let's get back to the van. Let's talk about the car. How many people were in the car? 50. How many total people do we have? 95. And what do we know about the vans? That they took 3 large vans. We want to know how many people are in each van. So let's say 3 times V. So if there's like, I don't know, 7 people in a van, 3 times 7. Okay, I'm just throwing that out there. However many people are in each van, that's what V is going to stand for here. So now let's actually put this into an equation that looks nice and what Ms. Traub was looking for. 3 times your variable plus 50 equals 95. So again, 3 times the number of people in each van plus the 50 people that got there by car equals 95, which is the total amount of people that went to the convention. All right, now let's figure out how many people took vans. So that's our first step. How many people were in all of the vans together? So let's get rid of these 50 car riders. If we get rid of the 50 car riders, we get that 45 people were in vans. So 50 people got there by car, 45 people got there by taking a van. We have 3 vans. So think of this. You're going on a trip with your buddies, 45 of your buddies. So that's a lot of buddies. You have 3 vans. How many people are going to need to be in each van? Well, you're going to divide by 3 to find that. V equals 15. What does that mean? There are 15 people in each van. All right, number 8. Which of the following is not a perfect square? Well, I guess you need to know what a perfect square is first, right? That was a 7th grade skill, those perfect squares. Let's talk about that real quick. Perfect square. So a perfect square is when you can take the square root of a number. Sorry, I'm off the screen there. The square root of a number, and it is a whole number, no decimal. Meaning, if you took the square root of 4, basically what you're asking yourself is what number times itself equals 4? What times what is 4? 2. Now we can use calculators, thankfully, to help us, okay? Because once we get into the bigger numbers, it's a lot harder. So how do you do that in a calculator? The square root of 4. So on these calculators, you have obviously the symbol or number or letters that are written on the key itself. But then I'm sure you noticed that on the actual calculator part above the keys are all these little blue symbols and words, okay? And if you look above the key right here, X, the one right by 7, X to the second power, right above it is that square root symbol. Now that square root symbol is called a radical sign, by the way. So we want to use that radical sign. And in order to use that, we're going to hit the second and this key. And you can see in my screen now, I have that radical sign and then parentheses. So if I want to find the square root of 4, I'd hit that and hit 4. I don't need to put the other parentheses in there. Hit enter and I get 2, okay? If we think about the square root of what number would give us 3, 3 times 3 is 9. The square root of 9 is 3. If we think about what would give us 4, 4 times 4 is 16. The square root of 16 is 4. These are perfect squares, okay? That's what that means, perfect squares. You take the square root of it, it is a whole number. Using your calculator will let you know that. So, for instance, 10, I didn't write down 10. So if I found the square root of 10, remember, second, X to the second button. Okay, so we have that square root 10. Look at that. It's a big, long decimal number. So it's not, square root of 10 is not a perfect square. All right, so we're going to do that for these problems over here. We're going to do the square root of 81, the square root of 144, the square root of 110, and the square root of 21. Which of these is not a perfect square? Meaning 3 of them are perfect, 1 of them is not perfect. So I'm going to start off by doing the square root of 81. So second, X to the second, 81. Oh, it's 9. 9 times 9 is 81. Square root of 81 is perfect. Square root of 144. 12. 12 times 12 is 144. It's perfect square. 110. Oh, not a perfect square. So this equals, let's see, 10.4880. This is a decimal number that does not terminate, that means stop, or repeat. Doesn't terminate or repeat, okay? That means it's irrational. And things that are not perfect squares are irrational, okay? So I'm pretty sure this is the one we want to choose, but we should always check our last option just to make sure. The square root of 121. 11 times 11 is 121. So again, these 3 are perfect squares, which are rational numbers, and this square root of 110 is not a perfect square. It is irrational, and that's the one that they were wanting here. Number 9, write 0.125 as a reduced fraction. Oh, okay, this is a throwback, right? Probably learned how to do this in 5th grade or 6th grade. So if you were going to read this number, I would just say 0.125, all right? If you were going to read it technically, it would be 0 and 125 thousandths. So you got to think about your place values, okay? So when we're thinking about, we have the 0 point, the first place value is the tenths, and then we have hundredths, and then we have thousandths. Anytime you're coming to the right of the decimal, you're going to have that THS on it, all right? Now, what happens if you don't know your place values? You don't know your place value names, because this is going to help us know it's going to need to be over 1,000. Well, there's a trick. Thank goodness, right? Take your 125, and we are going to use 10, 100, 1,000, 10,000, 100,000. These are our options, okay? Each one of these has one more zero. I hope you realize that. I notice that there are 1, 2, 3 digits in 125, 3 digits. So I'm going to use one that has 3 zeros, 1,000. So again, the amount of digits you have in your numerator matches the amount of zeros you have in your denominator. Just a little trick. This is 0 and 125 thousandths. All right, now, other part of this. This is technically right, but it does say reduced fraction. So we don't want to leave it like this. What can you divide both 125 and 1,000 by? Well, 5 would work, right? The divisibility rule for 5 is if a number ends in a 0 or a 5, you can divide by 5. So I'm just going to start off by dividing by 5. And that's probably not going to get me to my final answer, but it'll at least get me one step closer. So 125 divided by 5 is 25. And 1,000 divided by 5 is 200. Okay, same thing. You can divide numbers by 5 if they end in a 0 or a 5. So we can divide by 5 again. 25 divided by 5 is 5. 200 divided by 5 is 40. Well, look at that. It ends in either a 0 or a 5. So you can divide by 5 again. 5 divided by 5 is 1. 40 divided by 5 is 8. Now it is finally reduced. Now, if you wanted to do this in one step, instead of doing 3 steps like what we did here, 5 times 5 times 5 is 125. We could have divided both of these by 125, but I didn't know that I could do 1,000 divided by 125, okay? That's why I just broke it down into these multiple steps. And as long as you have a calculator, then it doesn't make it that much worse. All right, last problem, number 10. Number 10 is saying write 0.666666666 as a reduced fraction. Okay, one thing that I noticed is that this is a repeating decimal. A repeating decimal. What number repeats? The 6. So if I asked you rewrite 0.6666666 ... rewrite that to show that it's repeating, I would hope that most people would know that that means the same thing, right? So the way that we're going to write this as a fraction is kind of similar to up here. If this would have just been 0.6, now this is not just 0.6, this is 0.6 repeating. But if it was just 0.6, if we used our trick that I told you up here, remember your options, 10, 100, 1,000, 10,000. Those are your options for your denominator. And we said however many digits you have, that's how many zeros you want. 6 over 10, 6 tenths. That's what this is, all right? The trick with these that repeat, your 6 is still going to go on top. But instead of putting a 10 on the bottom, we're going to put a 9. Now look what happens. If I do in a calculator 6 divided by 9, 6 divided by 9, there it is. Now you may be thinking, why is that 7 there? That's not 0.6 repeating. There's a 7. The reason there's a 7 is because these calculators will round up. It takes up the whole screen. They run out of room. So they say, well, I'm going to round up. And that's where the 7 comes from. Okay. So this really is 0.6 repeating. Now she wants a reduced fraction. So what can you divide both 6 and 9 by? You can divide them both by 3 and get 2/3. thirds. Now that's your answer. I want to give a little extra tidbit. Really, 2/3. This is a common fraction. This is one that I'd really like for you to have memorized. Things that you should really have memorized: 1/4, 1/2, 3/4. Okay, sorry. Let me pull my camera down. There you go. 1/4 is 0.25. 1/2 is 0.5. Some people say 0.50. That's fine. You can have that 0 back there. 3/4 is 0.75. The other two most common fractions that you will see are 1/3 and 2/3. Both of these are repeating decimals. 1/3 is 0.3 repeating. And I call 2/3 its evil twin. Why am I calling it its evil twin? Why would I say that? Because it's 0.666 repeating evil, right? That's just a joke. But if it helps you remember it, hey, great. So whenever I see 0.6 repeating, I automatically know it's going to be 2/3 because that's just one of them that I have memorized. I would highly recommend having these 5 fractions and their decimal equivalent memorized. So if you see 0.3 repeating, you know it's 1/3. If you see 0.6 repeating, you know it's 2/3. Okay, that's going to save you a lot of time.